everyone. Welcome to my channel. This is Karuna, teaching the course Computer Architecture and Organization. Third unit contains the following topics. Fundamental concepts, in which we have discussed about how the data transfer takes place between the registers and also how processor performs arithmetic operation. With one example we have seen, and also how processor fetches the word from memory and what are the complete control signals are required to execute one instruction. To coordinate all the actions, how the control signals are generated with the help of hardware control. We have seen last class. Okay, in this video we will concentrate on microprogrammed organization. Introduction. To execute instructions, the processor must have some means of generating the control signals needed in the proper sequence. There are two ways to implement the generation of control signals. Those are hardware control and microprogrammed control. Last class we have seen how the control signals are generated by the hardware circuit to coordinate all the actions specified by the instruction. Now in this video we will concentrate on microprogrammed control. So here in last class we have discussed one example at R3, R1. So execution of complete instruction, processor needs to fetch the instruction first, and then here first operand is available in the memory. That memory address is specified in the R3. Okay, so that's what processor needs to fetch the operand. Next, add the operation on that fetched data according to the instruction, and then output will be transferred to R1. Okay, so to perform this instruction, these are the control signals required to generate. So we have seen in last video, these are how these control signals are generated with the help of hardware circuit. In this video, we will concentrate on how these control signals are generated with the help of microprogram. Okay, same sequence of steps we are using in this example, in this microprogrammed control topic. Okay, so here to perform that add instruction is macro instruction. To perform this that instruction, these are the steps required to execute. Okay, so in first step, what are the actions are performed? PC out, MER in, read signal, select for, add, Z in. Okay, next step, Z out, PC in, Y in, wait for memory function control signal. Okay, third step, MDR out, IR in. Okay. So these three steps are required to fetch the instruction first. And then fourth step, here fetching of first operand. Fifth step, getting the next operand from R1 register. And then sixth step, sixth step, addition operation is performed between the two operands. Seventh step, output is transferred to the R1 destination. Okay, so according to that instructions, according to that sequence, here in first step PC out. Okay, so PC out is set to 1. Next MER in, that is set to 1. Next read signal is set to 1 in first sequence. Likewise, the required control signals in the first step are set to 1. Remaining other bits are set to 0. Okay, so the combination of all these bits, nothing but control word, we can say instruction code. Okay, so each step we are considering as treated as a micro instruction. Okay, so micro instruction these are the combination of bits. Okay, each bit combination of bits are used as a micro instruction code, that is nothing but control word. Okay, so here micro instruction, we can say the combination of all these bits micro word or micro instruction. Okay, so this is micro instruction 1, 2, 3, 4, 5, 6, 7. Okay, 7 micro instructions are required to perform this macro instruction. Okay, so set of all these micro instructions known as micro routine for this execution of add R3 comma R1. Okay, so I hope you understand what is the difference between micro routine, micro instruction, control word. Okay, so with the help of this control word, the required control signals are generated. Okay, in first step. Okay, so likewise micro instructions are can be designed. Okay, so 7 micro instructions are required to perform one macro instruction, that is add R3 comma R1. Okay, next let us move on to the next slide. Basic organization of microprogrammed control unit. Okay, so to transfer microcontrol signals to the processor. Okay, so some small hardware circuit is required. That is, here instruction register contains the add instruction, add R3 comma R1. Okay, so to execute that instruction, some micro instructions are required. Okay, so this starting address generator used to generate the starting address of the micro instruction that will be loaded in program counter. Okay, so here micro program counter used to save the address of the next micro instruction. Okay, so micro program counter is used to store the address of the next micro instruction. Okay, at that address, whatever the instruction code is available, that is nothing but control word that will be transferred to the processor. Okay, so the program counter will be updated with the help of clock cycles. Okay, likewise, one by one micro instructions are executed by updating the PC to perform the macro instruction, to execute the macro instructions. This is the small hardware circuit is required to perform the micro program. Next, in previous case, we have discussed about branch instructions, conditional branch, unconditional branch. Here also in case of micro program, conditional branch or unconditional branch instructions are also present. Okay, so these are the micro control signals. So this is the first instruction which contains the following micro control signals. Okay, assigned to the 0 address. Next sequence assigned to 1 address. Next sequence assigned to 2 address. Okay, so if branch instruction occur, there are two types of branch instructions, conditional branch or unconditional branch. Okay, if condition branch occurs, if n equal to 0, based on this condition, then branch to micro instruction 0. Okay, then PC will be loaded with the target address, that is 0 address, because it has to jump to the micro instruction 0. Otherwise, execute the another instruction. So what is another instruction? Offset field of IR. Okay, so IR contains the unconditional branch instruction in which offset address is specified. That the offset address will be added to the PC content to generate the target address. Okay, at that address, the whatever the specified instructions, those will be executed. Okay, corresponding small hardware circuit is required. Okay, so here branch instruction address generator, whenever here according to the instruction available in the instruction register, generates the starting address of the micro instruction, and then if any branch occurs based on this input, external input and conditional code, then the PC will be uploaded with the target address, specified target address, and then at that address whatever the instruction code is available, that will be transferred to the processor. Okay, that code is also we can say control word. To the processor, processor perform micro instruction operations according to the control word. That PC will be uploaded with the clock cycle. Okay, likewise if the branch occurs, PC will be updated with the branch target address. Now let us see, if the instruction contains 42 microcontrol signals, then it requires 42 bits. Okay, so to store 42 bits of instructional codes, processor may require more memory. So to avoid that more memory usage, those bits are grouped together. Okay, by F1, F2, F3, F4, F5, F6, F7, F8. Okay, here in F1 group, 4 bits are used to represent out control signals. 3 bits in F2 group, 3 bits are used to represent in control signals. And the F3 group contains the in registers which are linked with the memory. Okay, so F4 group contains the arithmetic and logical operations. To represent 16 arithmetic and logical operations, it requires 4 bits. Okay, so likewise here, instead of using 42 bits here, here only 4 and 3, 6, 10, 14, 15, 16, 17, 18, 19. 19 bits are used to reduce the memory usage. Okay, so likewise instruction codes are assigned to the required control signals. Okay, so that's what this is known as partial format for field encoded micro instructions. So let us see microprogram sequencing. Okay, so for example, here add source comma destination instruction. Okay, here so add source comma destination instruction. Add is the macro instruction. Here source operand may be specified different addressing modes, that is indexed addressing mode, auto increment, auto decrement, register indirect and register direct addressing mode. Here the way of specifying the data is mentioned in different kinds of addressing modes. Those are 5 addressing modes. In this flowchart we can observe 5 addressing modes. In these 5 addressing modes, data can be specified. Okay, so here these are the first 3, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. Okay, at that address, whatever the instructions are present, in that instruction corresponding microcontroller signals are used to fetch the instruction code, add instruction code. So we have seen complete instruction execution topic, where first processor needs to fetch the instruction code, then processor needs to fetch the first operand, then next perform the operation on that data, and then output will be transferred to the destination register. Okay, here source may be specified in register direct mode, register indirect mode, auto increment mode, auto decrement mode. Okay, so here the direct mode, the address is 101 is assigned to the register direct mode. Okay, 111 is assigned to the register indirect mode, 121 assigned to the auto increment mode, 141 assigned to the auto decrement mode, 161 assigned to the index addressing mode. Okay, so here after these three steps, are used to fetch the macro instruction. Okay, from which branch instruction decoder comma or operation. Here branch instruction decoder is used to select either one of the addressing mode of the data. Okay, so here ORing operation is required to select either one of the, here alpha is there, no, so that is connected to indexed mode, auto decrement mode and auto increment mode. Okay, so here one OR operation is required, that OR operation can select either one of this input. Okay, then and also another OR operation is required to select these 5 kinds of addressing modes. Okay, so first 3 steps are used to fetch the instruction code, and then whatever instruction code present in the MDR, that will be transferred to IR. Okay, so after that processor needs to fetch the data. These all cycles used to fetch the data. Okay, so if the branch instruction specified here register direct. Okay, now PC will be loaded with 101. Then whatever here register direct means the data is available in the source register directly. That will be transferred to Y register according to the flow of execution diagram. Then if branch instruction occur, processor jumps to the specified branch, that is 172, where whatever the first operand content in first operand is available in the Y, that will be added to the content of destination register, then transferred to the Z temporarily. From that Z output will be transferred to the destination register, then stop the procedure. Next, if the branch decoder selects register indirect, okay, so in register address of the data is available, that address will be transferred to MER, then jump to the branch instruction 171, PC will be uploaded with the 171, then jump to the address, whatever the address here, at that address whatever the data is present, that will be loaded into MDR register, that transfer to the Y register. Okay, now perform add operation between first operand available in the Y and then destination register. Second operand is available in the destination register. Okay, so after performing this addition operation, output will be transferred to destination register through temporary register Z. Okay, now if branch instruction select auto increment mode. Auto increment mode is first effective address of the data is available in the R source, that is loaded into MER register. Okay, so to get the next data, R source will be incremented by 4 automatically. That will be again transferred to R source through temporary register Z. Okay, so now jump to 170. Okay, so here data is to be read from memory. That's what the process control unit issues read signal and then enters into waiting mode. Okay, so what is that sequence available at 170? Here, whatever the MER address, at that address whatever the offset is available, again that will be loaded in MER, and then at that MER whatever the data is available, that will be loaded in MDR register, then transferred to Y, then first operand is available in the Y, and then that will be added to the destination register content, then output will be transferred to the destination register through temporary register Z. Okay, so these are all common for all these. Addition is common for all these branches. Okay, likewise, auto decrement mode will be selected after getting first data source address. So address of the first data is available in the source register, that will be decremented by 4 to get the next data. Okay, so and then get the first operand and then perform addition operation, then output will be transferred to our destination. Here add instruction performs the addition operation between these two operands. After that output will be transferred to the destination register. Okay, so if indexed mode, the data is specified in indexed mode. If the instruction decoder selects the indexed mode, then PC will be uploaded with that branch address, then that will be loaded into MER. Again to get the next address, PC will be updated and then transferred to PC. Okay, where MER at that address, whatever the data is available, that will be transferred to Y. That Y is the displacement. Okay, so index some displacement, 8-bit displacement or 16-bit displacement, that will be added to the R source content. Okay, so R source content having some address, that will be the displacement is added to the source content, then that will be loaded in MER. Then jump to 170. Okay, at 170 here we have the sequence of actions. Here whatever the address is sent to the memory, at that address the offset is available, that offset address will be loaded into MER register, that offset will be loaded into MER register, that offset address whatever the data is present, that will be transferred to Y, and then that to first, now Y got the first operand, that first operand will be added to the R destination content second operand. Okay, after performing this add operation, output will be transferred to the destination register through temporary register JAD. Okay, likewise here 5 addressing modes of specifying the data are available. Each addressing mode is assigned some address. Okay, register direct having 101, register indirect having 111, auto increment mode 121. Likewise, addresses are assigned to each branch. Okay, so all these mode of specifying the data will be selected by OR operation. Okay, so here 171, 172, 173. These 3 steps are common to these 3 mode of these 3 modes: indexed mode, auto increment, auto decrement. Okay, 172, 173 common for all 5 mode of operations. Likewise, these are the different way of getting the data before going to perform add instruction. Okay, so these are all whenever branch occurs, jumps to the next address. PC will be uploaded with the next address, then processor jumps to that address, then execute the respective program. Okay, now these are the control signals required to perform whatever we have discussed in previous slide. Okay, so for all this is first step indicates the first instruction, next step indicates the next instruction. First instruction contains the following control signals, second instruction contains the following control signals. So each instruction is assigned with some address, 000 octal address. Okay, so 000 is at 000 address, first instruction is available. 001, second instruction is available. Likewise, all these kinds of instructions 0002, 173 instructions are required to perform the different types of addressing modes. So, wide branch instruction. Here, branch contains instruction decoder, nothing but wide branch addressing. Okay, whenever this branch instruction specifies the wide branch address, that is indexed mode or auto index mode, auto decrement mode, auto increment mode, register indirect, register direct. Okay, so here when whatever the target is specified by the wide branch decoder, then processor enters to that specified location and execute the corresponding micro program. Okay, that's what this is known as wide branch addressing. So small circuit, hardware circuit is required to execute all the micro instructions, to execute macro instruction available in the IR. So these are the conditional code external inputs. Whenever the branch jumps to the specified address based on this conditional codes or external inputs. Okay, so whatever the address this is the micro address register. Whatever the micro address register contains the address, that will be at that address. Whatever the micro instruction that will be loaded in micro address register, whatever the instruction code is available at that address, that will be loaded in micro instruction register. Then according to that instruction, control signals are generated. Okay, like that all micro instructions are executed in sequential manner by updating the next address. Okay, to perform that all operations, these are the group of micro instructions are required. Okay, now here, so in first address 00 address, these are the control signals are present. Okay, so all these control signals are present in specified groups. Okay, if you observe F0 group, F1 group, F2 group, in F0 group, address of the next micro instruction. F0 specifies the address of the next micro instruction. Here F1 contains PC out. Okay, So here F1 contains PC out. PC out signal is here PC out. PC out assigned with 001. Okay. So F1 contains 001. Okay. So likewise, the groups are specified according to the control signals. Okay. This is the instruction code assigned with the address 000. Okay. So first instruction code and the second instruction code. Okay. This is the second instruction code. Okay. Or we can say control word assigned with 001. Next 002. MDR out, IR in. Okay. So this is the third instruction code. Okay. Assigned with 002 address. Likewise, all these micro instructions, micro codes are specified and assigned with some addresses. Okay. So to implement that means generation of control signals with microprogram, this is the small hardware circuit is required. Let us move on to the questionnaire slide. Define micro routine. What is the use of micro PC? What is the use of micro instruction register? Thank you. We will meet in next video.